Hello, everyone. Can you hear me? Fine? Yeah. So I'll be talking to you about type hints in production, and in case you're not sure about what type hints are, it's static type checking, so very exciting. But first of all, let me introduce myself. I'm Angela Santin, as you can see. That's my email. I don't do Twitter, so you'll just have to send all the abuse to that email, and I'll deal with it personally. I work at Smarkets, and we're based in London. We're hiring, and it's a really good place to work, so if you're looking for a job, check us out. So what am I actually going to talk about? Static type checking, but it's going to be divided into three parts. First, why do we even consider doing static type checking? So our motivation. Then what are the different parts that are needed to get static type checking done? And then finally, how are we using them in production? So why? So Smarkets has grown a lot in the past year, but in the past 6 months, we've doubled in size. So that means a lot of new hires, a lot of code getting rewritten, a lot of refactoring going on, and all of this is happening with not a lot of documentation. I mean, you never have as much as you'd like, and then not a lot of tests. So, you make things, you're not sure if you've broken other things. So it's a bit difficult. One thing I'd like to say is that we didn't have like a ton of runtime type errors, so that was not really a motivation. It was more from the perspective of documentation. So let's dig a bit deeper into some of the actual problems, what we struggled with. So as I said, we doubled in size. So let's say we have a new hire, such as myself, because I've only been there for 6 months, and you're trying to understand what this code is doing, and it's written in Python, as you might expect. So this method is a batch process, and it takes in a bunch of members. What those members are, I don't really know. So, I'm trying to figure out what the line member.process does. So I search for the function def process, and no surprise, it's a pretty common method, so it actually appears 56 times. So I need to go hunt down and figure out, which method is actually being called, which is rather time-consuming. Another example is code refactoring. Let's say, as a new hire, you're trying to modify what this method is doing, the process method. You're trying to modify the interface in some way. So again, you have to try to hunt down where is this method being used, or where is this employee class being used, and does the process method get called? So it's, it can be difficult. So now that I've set the stage for, what we were struggling with, let's talk about typing. So this is more about the background. So there's plenty of definitions in academia about what a type is and what it isn't, but this is one example. So a type is a set of values that share some structural property. And to get more concrete, in Python, you could have something like this. You have a string and an integer. You're trying to add them up, and you know what's going to happen at runtime. There's going to be a type error because they're different types, and the operation of addition does not really work with them together. So we know what a type is. What is static type checking? Well, static checking, let's define that first. Static checking is checking for errors before runtime. So if we already know that, then static type checking is checking for type errors before runtime. And static type checking is kind of a big deal in languages. I guess languages are classified into either static or dynamic, but really it's more of a continuum depending on how many type errors before runtime a language promises to catch. So on the one hand, we have a language like Haskell, which doesn't catch everything, but catches a lot of type errors before runtime. We have languages like C++ and Java, which are traditionally called static because they do have static typing, but they may not catch everything due to casting or using pointers, so it can get a bit messier for a static checker to really understand what's going on and catch all errors. On the other side of the spectrum, we have dynamic languages. In the case of Python, it basically promises not to catch anything before runtime, so that's what we're working with. So what is required for static type checking? First, we need a set of rules that assign types to expressions in our program. We also need annotations in case the types are not obvious and we need to include something in the code telling the tool. Well, we also need a tool that will check to make sure the annotations and the rules are actually in line with each other so that they make sense. So these are the three components that we need. And you know, I mean, it's kind of a contentious area. You know, there's people who are very much in favor of static typing, others who are not, and there's good arguments on both sides. Some of the arguments on the dynamic side is that I can write code faster because I don't have to think about types in advance. I can write more concise code because I don't have to be explicit about my types. And also, I can benefit from flexibility because sometimes a type checker can be very picky about the programs it accepts, and a program that might not have issues at runtime could fail during the type checking process. On the other hand, those who are proponents of static type checking will tell you, well, you know, static type checking helps me catch errors before runtime. It helps my IDEs help me by doing things like autocomplete. It can also allow the compiler to optimize my code. So if I know, you know, the compiler knows how much space is going to be needed for a variable, it might optimize in terms of space. And then finally, it just makes it easier to read because I know what things are being passed around, what type they are. I kind of blurred out the allow compiler to optimize code because that's not really what the static type checking that's being done in Python is doing. So just, you know, that's just something that can be done with static type checking, but not necessarily a goal of the current state of things for static type checking. So going back to the problems, you know, we had two problems, understanding code and refactoring code. For understanding code, so here is the same function, but we've annotated with what the type of the object that we're taking in is. So in this case, you know, we know that members is a list of customers. So now you look at the member.process and you're easily able to figure out what it does because you just look for the customer class and woohoo, there's only one. And the refactoring case is similar. So we've annotated our function. Hopefully, we've also annotated code in other locations. So when we modify the interface of a method, well, if we apply some type checker, let's call it mypy, we apply it to our program files, and it's able to tell us, oh, hey, actually, because you've modified the process method, all of these type errors are cropping up, so you need to go and deal with them. So you kind of get a to-do list of the places you need to go look and fix. So, you know, it sounded like a pretty reasonable thing. It sounded like it was fixing our issue. So is this a new thing? Well, and when I say is this a new thing, I mean like adding static type checking onto a dynamic language. Well, not really. So JavaScript has done it, PHP has done it. So in the case of JavaScript, it was introduced as TypeScript. In the case of PHP, Facebook introduced it with Hack in 2014. And I mean, both languages have other features, but one of the key things that they introduce is the ability to add types to your code. So what about Python? I mean, I said we need three things to have a static type checker. We need rules, and those are already specified in those PEPs. We also need annotations. Those are covered. And we did type checker. And the specifications for the type checker are in PEP 484. So it seems like, you know, we're ready to go. So what does this syntax look like? In Python 3, we have the function annotations. So in the case of function annotations, yeah, so you can see I've annotated two variables with list of integers. The name is a string, and the return type is a Boolean. So that's for function definitions. If we're dealing with variables, the syntax is not as pretty. You have to put it inside a comment, but it works. So in this case, we're telling our static type checking tool that we have a list that is of type integer. Python 2, you can also add type hints, but there's no annotations there, so you have to do it in comments. But you know, they work fine. So you know what the annotations look like. What can we actually put into the annotations? So if I was talking about that in detail, it would basically take up the entire talk. So I'll just go into a couple of them just to give you an idea. So some of the supported types are, as you might expect, user-defined classes and built-ins. So in this case, we've defined the class email sender. And now we're going to use it somewhere else. So we have a send method somewhere in some other module. We import email sender, and now we know that what's being passed in is actually an email sender. You can also see that in the email sender, we have a return type of none for the init method. So that's also an annotation telling us that init doesn't return anything. And in the case of send, well, it returns a Boolean. Another maybe more exciting example is taken from the typing module. So it's a module that it comes with Python 3.5, but you'd have to install it if you're doing it in other versions of Python. So it defines a few classes that are very similar to abstract base classes, but they also give you the ability to index them. So you can say what the abstract base class is going to contain. So let's go with the example. So we import iterable, which is anything that implements the iter method. And in this case, we're saying, we have a greet all method that takes a bunch of names, and they're an iterable, and the iterable is going to contain strings. There's other examples, sequence, dict. You can check out the module and see what there is in there. Finally, any. Any is what allows gradual typing to happen, which we'll talk about later. But in essence, any is the subtype and the supertype of everything. So it allows you to do dynamic programming whilst using type annotations. So in case that was not very clear, let's look at the example. So in this case, we're saying that A is equal to none. But we're telling the static type checker, actually, it's not really of type none. We're actually dealing with an any type. And what that lets us do is in the next line, we call split on none. And because we've told the static type checker, actually, it's not none, it won't tell us that it's an error. So, in this case, it seems like it's not very useful, but it can be useful if it gets complicated to annotate things and you just want to, not deal with the static type checker. So there's plenty of other examples, as I said. You can find resources. There's generics, and there's a lot of exciting stuff. But let's talk about the last missing piece, which is the tool that we're going to use to verify what we're saying. So there's a variety of tools, PyTerms and IDE. It's useful. I use it, but not everyone does. Then there's PyLint, you might use it for linting, and they said they're going to add it, but it's not there yet. PyType is by Google. It's a bit experimental, so we're not really using it. And then finally, MyPy, which is kind of like the de facto, and it's the type checker that I mysteriously added earlier. So MyPy, let's keep going. So installation, the reason why I included that was because there is a package called MyPy, and that's not the one you want to install. It's actually MyPylang. And in order to run it, you just do MyPy and your files, and that will double check if everything's all right. If you don't have any annotations, it won't bring up any errors. It's only when you start adding annotations that you'll get feedback on whether what you're doing is correct. So the type checking works in 2.7 and anything above 3.2. But you must run it from Python 3. And one recommendation is be on the latest version, because there's just a lot of, it's in very rapid development, so a lot of bug fixes are coming in all the time. So we're running 0.44, which is the latest version. So, how do we actually incorporate it into production? We're using these type checks as a way of documenting and making sure our code is correct and we can understand it. So we want to make sure that we can trust them properly. So that's why we've decided to incorporate it as part of our continuous integration. So we push code, right? And tests are run on that code. So integration tests, unit tests, other linting, flakate, PyLint that you might be using. And then we just added MyPy on top of that. So it's kind of like a linter on steroids. And this is, as I said, just to ensure that you can actually trust the annotations. And you might have the question, I'm going to add it to my CI. Is it just going to slow everything down? Well, we found that it doesn't really. It takes a few seconds, like 5 seconds. Obviously, it depends on the amount of code which you've annotated, but I'll show you that later. And if it's not fast enough, they are working, so the MyPy team are working on making it faster, basically. And there's 2 flags that you can experiment with. We use incremental, and it makes it a bit faster, but you might not even need that. So as I was saying, how much of our code have we actually annotated? Well, we have around 300,000 lines of Python code, and we've annotated 20,000, which is a lot. However, it's still only 5% of what we have, which, is not a lot. And the reason we've been able to do that is because MyPy implements gradual typing, which is basically, if you've annotated your code, we will check for or there's type errors. But if you haven't, then we'll just like ignore it. So in this case, this is just to highlight that, the subtract method, you can either annotate it with any types, and the type checker will just, be like, okay, you can do whatever you want with those variables, or you can just leave it without annotations, and it's kind of like the type checker backs off. And it's very useful, right? Because you can't, like, it's kind of a ridiculous expectation to have you annotate all your code base. So yeah, this allows you to do it incrementally, which is very nice. So what about third-party libraries, you might be wondering? Well, there is growing support, and there's going to be a talk right after this one talking about that. At the moment, we basically are not really using a lot of annotations for third-party libraries. But what you can do is first start by ignoring them, which MyPy supports, and don't worry about third-party things, or things that you cannot annotate. And then as you incorporate, as you want to add more, you can basically just add more. But more will be said in the next talk, so I won't go into that. Big question that we had is, what do we do about duct typing? So hopefully, so yeah, duct typing. What is duct typing? If it quacks like a duck, it's duck, or something along those lines. So in this case, if we pass in an object and it has the method quack, then our code will just run and everything will be fine. So are we able to still do that, have that functionality with if we add type checks? Well, you can think of multiple solutions. You could say, I'm not going to annotate my code at all, like, won't bother. You could use the any type, which we've seen kind of basically does the same functionality. Or you could do a union of types. I didn't mention this, but it's in essence like you would say, I can pass in a string or an integer or whatever classes you've defined, and any of them are OK to pass in. So the input would be any of those types. But as soon as you get a lot of different types that are possible to pass in, it can get really messy, so it doesn't seem like the right choice. So what we've done is, it might not come as a big surprise to some of you, is implement an abstract class that we then inherit from. So below here, we have an abstract Duct class, which has a quack method. And then in our original method, in our original function, we say that we can pass in anything that is of type Duct. So if whatever we want to pass in, we'll now have to inherit from Duct. So this works, and it can actually make you think about the hierarchy of your types in maybe a nicer way. But if you have a lot of Duct typing, it can get really messy. Like you're adding, abstract base classes just so you can do Duct typing here and there. It just doesn't feel great sometimes. Ideally, we wouldn't have to do this, and so my question is, can we avoid subclassing? Well, right now, not really, unless we kind of like not annotate or do the suggestions that I said initially. There is, however, a discussion going on, which is interesting, which is adding support for protocols, which for those of you who have used languages like Go, it's kind of like similar to interfaces, which is in essence, rather than assuming that an object is a subtype of something else, by explicitly having to specify it, you can just, as long as an object implements the quack method, then it can be considered to be of a protocol supports quacking. So in this case, you wouldn't have to actually inherit from supports quacking. You would just, as long as you implement quack, you're fine. So this sounds very nice, or at least it sounds very nice to me. It's not really there yet, but there's a lot of discussion going on, which we can read more in this GitHub issue. I thought it was interesting. And then, so, have we run into issues? Well, yeah, MyPy is not perfect. As I said, it's in development. So just like a small issue that we found is, in this case, we have a method where it takes in a Boolean, and in some cases, it will return hello friend, and in other cases, it will return none. So that's what the optional syntax is saying, like, maybe a string or maybe nothing. So if you say something like that, you would expect that if we call greeting with type false, nothing's going to be returned, so we would expect the type checker to figure out, oh, hey, like the type is none, so you shouldn't be doing this. It should be a type error. And at runtime, you would get a type error. Sadly, you run MyPy on your hello file, and nothing happens. So yeah, that's just an example of an error. In this particular case, if you use the strict optional flag, you can catch that. But this is just an example of like little things that it may not catch, you might be surprised by, but they are getting fixed, so it's good. And then finally, does MyPy get in our way? How much do we have to ignore MyPy? This is not really like a good, like the best maybe count of how to estimate how much we're annoyed by MyPy. But like when you add type ignore, it basically tells the type checker, ignore this line, don't worry about it. And then any, as I said, it's basically a way of doing dynamic typing whilst having the type checker run through your code. So the total times that we use those two indications to tell the type checker to back off, it's just 2% of our code. So we don't have to ignore it a lot, which is good. So that's almost at the close in terms of what people are saying at Smarkets about it. Well, get a wide range of responses, mostly positive. I think people are generally happy. So it's a mystery how we were able to be productive without static type checking. But as I said, it is a contentious area, and some people feel strongly. And I hate static type checking. Leave me alone. I also got that sort of response. So, but it's mostly in the positive side. So it's good. I think we're overall happy with it. Yeah. So I think overall it's improved our understanding of the code, or it's helped us understand the code better. It helped us refactor. It's easy to incorporate into your CI. It doesn't take a lot of time. And it will help catch some errors, not all of them, but some. And then it's not perfect, but it's improving quickly. And there's a lot of movement going on there. So it's certainly worth a try and a test and see if it can help you. And that's it.
Thank you very much. We have 3 minutes for questions. If I can get questions line up here, please.
Hello. I wonder where the fast Python don't bother guy is, because you can probably say, Python's finally getting parametric polymorphism. Hooray. Have you had an experience with something that's both Swift and TypeScript that you do? So if you have an optional type, they use the knowledge of if statements and that kind of thing to say, if you go if is not none, inside the context of that if statement, it knows that it's T, not optional T. Is there anything coming for Python like that?
As in the static type checker being knowledgeable enough to figure out,
yeah,
you have all these if statements. I mean, so it tries to do that, but it doesn't always do it well.
Right.
So that's the issue. It won't catch everything. It tries its best. I can't give you specific technical details. But I think it's being worked on.
It sounds like something that'll eventually be there in MyPy.
So how did you guys decide where to start doing your annotations?
It's a great question. So our the way a code is structured is there's a monolith. I mean, it has multiple components, but in essence, it's a bit of a monolith. And then we have microservices, which are smaller. So we started with the microservices one by one, see how it works. And then when we saw that we were happy with it, we kind of moved on to the monolith and tried to annotate that.
Just a quick follow-up.
Yes.
Had you considered doing any kind of static analysis on your repository or code to see most committed files or anything like that, just to say stop right here, or did you just start main.py or something?
Did we start where, sorry?
Just your main method or whatever, at the beginning of the program. I mean, just kind of getting an idea on from an individual program or microservice where to start.
Sorry, I'm having trouble hearing, so.
Within a specific microservice,
yes.
How did you decide where to start on that level?
I don't know if we used a specific method. I guess just try it out.
Okay.
There wasn't. Yeah, sorry.
Hey, hi. From my question, it might be obvious that I don't use type checking, but something that seems to me that would get really fast in the way is cross-referencing. So if you have a book, and you define your class book, and the book has several chapters, so at some point you would need to type something as returning chapters. But chapter is not defined yet, and you cannot define chapter before book, because in chapters you also reference book that you would need to add in type checking. So how do you deal with that?
So I'm blanking out on the name right now, but there's a way to kind of do forward references that should deal with sort of scenarios. In terms of circular imports, that's also dealt with somehow. We haven't really run into issues, but if, for instance, you're trying to refer to like the same class within the class as you're defining it, there's a way to deal with that. I think it's forward references. That's what it's called. Yeah.
Okay. And
I don't know if I answered your question, but I'm having trouble hearing, so.
somewhat, yeah.
Okay.
I hear that when I was reading about how PyPy accelerates code, is that it will find out what's a routine is being run with, what the types of the arguments are, and if it sees it again, it will say, I've got this bit of code, I'll run it for that type of. So it's actually extracting type information from running programs. And I'm thinking, I've got code, I'm not too hot on types particularly, but if there was a tool, if I could run it through PyPy and PyPy said that for this execution, this is a type annotations, please, that's what I want.
Yeah, so in essence, you want to be able to annotate it automatically, I guess, right? Or, so that is, so with MyPy you can do that, but you'll get the annotations in a separate file, on a .pyi file. So we wanted the annotation to be in our code, so that's not really possible as far as I know right now. It is possible with PyType, which is the Google experimental type checker, but that one has other issues. So that one can actually it does it in two phases. First it creates the .pyi files and then it merges them back in. There's a talk actually, it's in the references, so yeah, it can be done, yeah. But
Fantastic, thanks very much, Angela.